we're asked to graph this function, finding the roots and the vertex of this parabola. So to find the roots, when people talk about roots, they're talking about the points of intersection of this function and the x-axis. So this is the x-axis here. This is the y-axis. And you're going to intersect the x-axis when y is equal to 0. So to find the roots, we set y is equal to 0. So we solve the equation x squared plus 4x minus 12 is equal to 0. All I did is I set y is equal to 0, and then I swapped the left and right hand sides. Now, to factor this, we have a 1 as a leading coefficient. So we don't have to do the kind of the all-out grouping. We can just think, are there two numbers whose product is negative 12? And if I add them, I get 4. So let's think about it. It looks like 2. Positive 6 and negative 2 would work if I would go through all of negative 12's factors. So this can be factored as x plus 6 times x minus 2. 6 minus 2 is 4. 6 times negative 2 is negative 12. So that's going to be equal to 0. And if we have two numbers, and if when you multiply them we equal 0, that means that either x plus 6 is equal to 0, or x minus 2 is equal to 0. Subtract 6 from both sides of this equation, you get x is equal to negative 6. Add 2 to both sides of this equation, and you get x is equal to 2. So y is equal to 0 when x is equal to negative 6, or x is equal to 2. So let's graph both of those points. X is equal to negative 6, y will be equal to 0. So x is 1, 2, 3, 4, 5, 6. So negative 6 comma 0. That will be on the graph of this function, or the graph of this parabola. And also the point x is equal to 2. X is equal to 2. So 1, 2. Just like that. X is equal to 2. So this is the point 2, 0. Now to find the x value of the vertex, there's actually several ways of doing it. There is a formula that gives it to you. But actually the easiest way to figure it out is it's actually going to be the midpoint between the two zeros. If you already figured out the zeros, the x value where the vertex is going to lie, because because the two zeros are always symmetric around the axis of symmetry, which is the same x value as the vertex, you could just find the midpoint of these 2 points, and that will be the x value of the vertex. So let's just do that. So if we take the midpoint, we can literally just average these two numbers. So negative 6 plus 2 over 2 is negative 4 over 2, which is equal to negative 2. So the vertex is x is equal to negative 2. And when x is equal to negative 2, what is y? Y, so this is x is the vertex, and then y will be equal to negative 2 squared is positive 4. 4 times negative 2 is negative 8. And then we have a minus 12 there. So 4 minus 8 gets us to negative 4 minus another 12 is negative 16. So the point negative 2, negative 16. So the point negative 2, negative 16 is going to be our vertex. So let me graph that. I think it's going to fall off of this graph a little bit. So negative 2, and then we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's going to be right around here. We went off the graph paper. But negative 2, negative 2, negative 2, all the way down to negative 16. So that right there is the vertex. Negative 2, negative 16. All the way down here. We can lower the y-axis. And so if I were to graph the parabola, it would look something like this. It would look something like that. Just like that. And obviously, it would keep going. Now, I figured out the vertex in this problem just by averaging the x values of the two roots. That gave me the x value of the axis of symmetry, which is this right here. X is equal to negative 2. That's the axis around which the parabola is symmetric. The other way to figure out the x value of the vertex is to use the formula negative b over 2a. So you could also, the x value of the vertex is equal to negative b, negative 4 over 2 times a. A is 1, so over 2, which is also going to give you x is equal to negative 2. Now, the last way to solve for the vertex is to complete the square, on this parabola right here. So what we can do is we can rewrite it. We can say this is y is equal to x squared plus 4x I'm going to put the minus 12 out here. And what we want to do is add and subtract the same number so I can express this as a perfect square. So if I take half of 4x, or if I take half of 4, I get 2. If I square that, I can add a 4 here, and then subtract a 4. And then what that does is it turns that into x plus 2 squared, right? X plus 2 squared is x squared plus 4x plus 4. We've seen that multiple times. So you have x plus 2 squared, and then you have the minus 4 minus 12 minus 16. So this is just another way of writing this exact same function. But when you write it this way, you see that the lowest point, this value, this part of the function right here, that part of the function is always positive. It's a quantity squared. The lowest value that it can be is 0, but then it can only go up from 0. So the lowest point, the lowest y value we can take on is when this value, this expression right here, is 0. And when that happens, the y value is negative 16. Now, what x makes this value 0? Well, x equals negative 2 will make this 0. If you wanted to say x plus 2 is equal to 0, this expression right here is going to be 0 when x plus 2 is equal to 0. Subtract 2 from both sides, x is equal to negative 2. So that's another way to find the vertex. All of them equally valid.